In understanding astronomy, it's not just sufficient to know things. You want to understand things. And to understand things, it's often helpful to learn about how did we come to figure out the things that we know. And so that involves a little bit of the history of astronomy. And I've always found it interesting, but as I grow older, I find it even more interesting, the history of astronomy. We talked in our previous few slides about a few lectures about ancient astronomy and how the ancient people started to figure things out. Ptolemy was probably one of the greats of ancient astronomy because he studied so much and he wrote down so much in the Almagest. Now, unfortunately, much of the Almagest was lost and to Europe. The Arabs kept the Almagest alive, what survived the fire in Alexandria. But most of Europe actually went backwards to Aristotle. And so they were studying Aristotle and Aristotle's concepts of things and how we fit into the universe. And that seemed, not to be exactly correct in how you calculate things. And this was a major issue because by the time that you got further into the Middle Ages, then people were starting to question again how the universe works, and they noticed that Aristotle's calculations failed to adequately or accurately predict where the moon and the planets were going to be in the future. You got the basic idea, but not the details. And so this became something of a conundrum. One of the biggest problems was retrograde motion. The retrograde motion was completely a failure in terms of Aristotle's calculations. Completely could not explain this. This is where the idea of cycles, or epicycles and deferents came through, goes all the way back to the ancient Greeks, also back to Pythagoras, and trying to explain why this would work. And it looks like it should work. Remember that we've got the ideas here we've got the ideas of the ancients here, where you have the heliocentric idea in which everything goes around Earth, but that could not explain why sometimes the stars looked like they went backwards. And so this is where the idea came about of the motions here in which you have epicycles that look like they ought to go backwards. And the idea seemed to make sense. It sort of seemed like it made sense to the ancients because they did not have the mathematics to describe that. Because it would look like the epicycle is going around, the planets are moving forwards, then the epicycle goes backwards, looks like the planet should move backwards in the background sky. And so that seemed to make sense. Okay. But it didn't. We talked about how Aristotle had figured out that the Earth was spherical. Explained the phases, the moon. They even were starting to figure out a little bit about why the Earth had seasons. And then you also had Eratosthenes, who figured out the size of the Earth. Now, when I was a kid, I was told, and this is true for many people in North America, that Christopher Columbus was the first to figure out that the Earth was round. And that's what I was told when I was a kid, and I believed it, but that's not right, because clearly Aristotle knew the right shape of the Earth, and Eratosthenes shortly thereafter figured out the right size of the Earth. And so why the discrepancy here? Well, Columbus sailed across and found the Americas, and so we tend to give him a little more credit perhaps than he's due for figuring things out. We thought that when I was a kid, we were told that he had trouble getting backers for his journey across to the New World because people thought they'd sail off the edge of the earth because it was flat. Well, that's not really the true, because in 1492, when Columbus actually set sail, this globe, which is now in a museum in Europe, was actually sold in a marketplace, the same marketplace that he left from. So everybody knew the shape of the earth and the approximate size of the earth. So the question is, well, why did no one want to fund his expedition? And these are actually other globes that were sold, that were manufactured and sold prior to Columbus's trip. Now, some of the shapes of the continents are off because they didn't really have good mapping skills. The other big thing here is there's this vast expanse of blue right there, okay, ocean. And that is the problem, because most Europeans realized that if you set sail, you can only go so far, and then you run out of food and water. So you go sailing west for thousands of miles, you're out of food and water. But it would take far longer to get all the way around to get to Asia. Well, that's the thing. They knew you couldn't do it. They knew that from Europe to sail around all the way to Asia was going to actually be longer than if they took the land route. Columbus did not know that. Columbus might have been famous, but he was actually a very poor navigator and a very poor mathematician, because he thought it was a short distance to Asia from Europe if you sail west. In fact, he thought it was much shorter than taking the land route. So, in other words, this right there was Columbus's map of the world. He did the same kind of calculations that Eratosthenes did, but he did them wrong, and so he thought the Earth was vastly smaller than it really was. And so that's why no one would fund him, because they thought you'd only sail out about this far and run out of food. In fact, by his calculations, he had already sailed past, he was running out of food, he had already sailed past Japan, which he was going for, and he was close to India by the time he finally landed in the New World. Okay, and that's why he called the people that he found there Indians. In fact, to compound the problem, he actually sailed back and forth several times before he realized that he was not where he thought he was. And so Columbus was actually wrong. He actually got lost and got lucky and found land, but other people did know the size and shape of the Earth.